Okay. Hi everyone, my name is Ava Bowie, and today I'm going to be presenting my international case study on the Pemex pipeline spill, water overuse, and population of Veracruz, Mexico. So my goal is to explain what happened, why it matters, and why it connects directly to the modules and concepts that we've been learning about water overuse and pollution, and the sources of surface and groundwater contamination. So, on October 21st, 2025, torrential rain in Veracruz, Mexico caused a Pemex pipeline rupture. Crude oil spilled directly into the Pantepic River, and because the area was already flooding, the oil spread quickly across farmland, wetlands, and nearby villages. This destroyed crops, killed animals, and contaminated drinking water. This event is a good example of how extreme weather and industrial infrastructure failures can combine to create a large-scale environmental disaster. And you can see Veracruz is over here. So, looking at Mexico before the spill, Mexico's water system was already stressed. Industries like Pemex used extremely large volumes of fresh water for drilling and refining, which leaves less clean water available for communities and ecosystems. At the same time, climate change is increasing the intensity of rainfall and flood events, making pipeline ruptures more likely. Valjeravic's 2025 study showed that same pattern in Venezuela, where oil extraction both overuses fresh water and pollutes nearby rivers. So the Pemex spill wasn't an isolated accident, but it is a part of a broader regional issue that's going on. So why is this important? This matters because water pollution and water overuse directly affects human health and ecosystem stability. When industrial facilities overdraw fresh water, there's already less clean water available. And when a spill happens on top of that, the remaining water becomes contaminated. Events like this interrupt drinking water supplies, harms local food systems, and puts entire communities at risk. Understanding these connections helps us to develop better prevention and management strategies in the future. So, what was detected exactly in this water? The main pollutants detected after the rupture were petroleum, hydrocarbons, and heavy metals like lead, cadmium, and nickel. Hydrocarbons reduce oxygen in water, which suffocates fish and other organisms. Heavy metals settled into the river sediments where they can persist for years. Navarrete and Rodriguez are colleagues, and in 2020 study from another Mexican river system, they found the same thing, that heavy metals bind to sediments and remain there after the water appears clear. This helps explain why cleanup after oil spills is so challenging. It is important to know that these pollutants do not stay in surface water, but they sink into sediments where they can later link into groundwater aquifers. In this case, contamination did in fact spread through both surface water and groundwater. Flooding carried oil and metals through runoff, coating soil and flowing into rivers, lakes, and eventually the Gulf of Mexico. At the same time, contaminants seeped down through porous soil into underground aquifers. Once underground, hydrocarbons and metals bind tightly to sediments, making them very difficult to remove. Baruch and Garduza 2022's study, research on shrimp in the Gulf of Mexico, showed that metals from inland rivers eventually accumulate in seafood, proving how surface pollution enters the food chain. Together, the study and the previous one I mentioned in Navarrete and Rodriguez shows how one spill can contaminate an entire hydrological system, not just what we see on the surface. This shows how a single spill can contaminate an entire hydrological system, from surface waters to underground aquifers. Essentially, this relates to the module on surface and groundwater use that we learned about in Module 7. Before I move into water overuse, I want to show just how this spill fits into the natural water cycle. On this diagram, I've circled surface runoff, infiltration, groundwater storage, because these are the key processes that explain how the Pemex spill spread through the entire watershed. When the pipeline ruptured, floodwaters created surface runoff, which carried oil across the land and directly into the Pantepec River. At the same time, oil and heavy metals seeped downward towards infiltration, entering soil layers and eventually reaching groundwater storage, which includes wells and aquifers that local communities rely on. So the spill just didn't just stay on the surface and entered multiple parts of the water cycle, which can make contamination even harder to clean. Moving on, as we know, oil extraction requires enormous amounts of fresh water, which worsens scarcity in regions like Veracruz. When industries withdraw water, rivers and groundwater systems become more fragile and are less able to recover from pollution. Vajarevic's work shows that when high industrial demand is combined with contamination, it creates less severe water stress. In Mexico, this means that it creates severe water stress. In Mexico, this means that less clean water for farms, households, and ecosystems. Overuse in population can push freshwater resources past a sustainable limit, and this is essentially what we learned in the overuse and consequences model in Module 7. So now, how does this affect the living organisms involved? Well, one of the most important, least visible impacts happens at the microbiome level. Microorganisms like bacteria are essential for natural water purification. They break down organic matter and help keep rivers healthy. When oil coats river sediments, it cuts off oxygen and kills these beneficial microbes. Carol Garcia's 2024 study in Ecuador showed that hydrocarbon pollution significantly reduced bacterial diversity and changed sediment chemistry. The Pantepic River likely experienced similar effects. This microbial damage explains why rivers take years to recover even after the visible oil is gone. For human impacts, the impacts were immediate. Farmers lost crops because of the irrigation water became oily and many fields were damaged. Fishermen lost income after widespread fish kills and contamination, and residents near the water reported unsafe drinking water and even skin irritation. Back to Brooke Goddard's research about how metals from polluted water move into seafood. It just means that communities downstream also face long-term health risks with eating these types of seafoods and foods. Events like this clearly show how the water overuse and pollution affect public health, food security, and local economies. So how can events like this be prevented or mitigated? First, maintaining pipelines and monitoring for pressure changes can reduce the risk of ruptures during storms. Emergency response systems also need to be strengthened. For cleanup, sustainable methods like bioremediation, which is using bacteria that break down hydrocarbons, are extremely effective. Natural absorbents like coconut fiber, sawdust, and clay can also capture oil from water and soil. Argrihippel 2025 review found that these eco-friendly methods reduce hydrocarbon pollution significantly. And finally, limiting industrial water and withdrawals during droughts and floods help protect water availability. So in conclusion, the Pemex pipeline spill shows how water overuse and pollution are deeply interconnected. Overusing water weakens river systems while pollution destroys the limiting clean water that remains. Scientific research helps us understand how these contaminants move and persist, and this knowledge is essential for improving policy and prevention. Protecting our water resources ultimately means protecting both ecosystems and communities that depend on them. These are my article references, and these are my photo references. Thank you so much.